Hello, geometry. Today we're learning about proving lines parallel. This is Unit 3, Lesson 3. So, proving lines parallel. You can prove lines are parallel by using the following reasons. So we've got a picture in the top the top right. Line L and line M are parallel. So, corresponding angles converse. This says that if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So remember, corresponding angles are the ones that slide on top of each other. So in our picture, an example of this would be if angle 1 is congruent to angle 5. Angle 1, I could slide on top right here of angle 5. Then L is parallel to M. Line L is parallel to line M. If angle 1 is congruent to angle 5. So, I could say those angles are congruent because I could slide those on top of each other. Okay, another one. The alternate interior angles converse says that if two angles are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. So again, this is backwards from what we've been doing. That's why it's called the converse. We're flipping those things. So, if we were to compare alternate interior angles, that could be like angle 4 and angle 6 up on the top right. So if angle 4 is congruent to angle 6 because they are alternate interior angles, then line L is parallel to line M. And it's all because they are alternate interior angles. So we could also say angle 3 is congruent to angle 5. Okay, using the same but different properties, using the same example in the top right. If two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. So angle 2 and angle 8, those are alternate exterior, opposite sides of the transversal and pointing outward. Then the lines are parallel. So if angle 2 is congruent to angle 8, then, that does say then, line L is parallel to line M. So if they tell us angle 2 is congruent to angle 8, the alternate exterior angles. And then lastly, using those same angle properties, consecutive interior angles. If two angles are cut by a transversal so that consecutive interior angles are supplementary, so they add to equal 180 degrees, then the lines are parallel. So this one's a little different. It says that if angle 3, that consecutive interior angle to angle 6, if angle 3 plus angle 6 equals 180 degrees, then because they are supplementary and they are consecutive interior angles, so we have to have a picture that shows that, then L is parallel to line M. So if the measure of angle 3 plus the measure of angle 6 equals 180 degrees, then line L is parallel to line M. Okay, so putting those into practice, what this looks like. So, given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. So we're just going to be stating which properties we just used, or converses, apply. So, in letter A, angle 2 is congruent to angle 4. So we can see that they are corresponding angles. So, and they share the same line. They share this line A. So because they share line A and they're corresponding angles, we can say that line A is the transversal because that's what they share. So the lines that they rest on besides the transversal are the parallel lines. So we could say that line C is parallel to line D because they share that transversal A. And we could say this because of the corresponding angles converse. So since it says converse at the top, we don't have to write it necessarily. I am right now, but you don't have to in the future because it says converse at the top. As long as we know, oh, corresponding angles tell us that. Okay. So the next one. Angle 5 is congruent to angle 10. So those angles share line C. So that's the transversal line C. So those angles are alternate interior angles. So the lines that they don't share. So A is parallel to line B because the transversal C goes through them. And they are alternate interior. So alt-int angles. Okay. Angle 6 plus angle 10 equals 180, which we can see they are in between the parallel lines. They are consecutive. They're on the same side of this transversal C. So that tells us they share the transversals. So A is parallel to B because they are consecutive interior. So int angles. Because they are consecutive interior angles. So that's the consecutive interior angles converse. That tells us that. So it's all about finding your angles. Okay, angle 1 is congruent to angle 14. They share the transversal C. This line right here, trying to bold it. So angle 1 is congruent to angle 14. Well, they're alternate, they're opposite sides, and they are pointing outward. So that tells us that A is parallel to B because of alternate exterior angles. Okay, so angle 14 plus angle 15 equals 180. So here's angle 14, here's angle 15. Those are on the same side of this transversal B. And they are in between. So that tells us that they are consecutive interior angles. If they're consecutive, then the lines that they don't share are parallel. So C is parallel to D because they are congruent. I'm sorry, because they add to equal 180 degrees. Angle 14 and angle 15 are not congruent because they face the same way. We cannot say that for certain. Which makes sense because one of them is an acute angle and one of them is obtuse when we look at that picture. Okay. Angle 11 is congruent to angle 16. How do we know that from the picture? Angle 11 is congruent to angle 16. Well, they are vertical angles, so they're congruent. We can say that. But vertical angles doesn't prove that anything is parallel. It just says that those angles are congruent. We don't have to have vertical lines to say that these things are true. So, because of that, this is a none. None apply. Vertical angles doesn't tell us anything about parallel. Vertical angles is its own thing. They tell us that they're congruent. Doesn't help us with parallel lines. So no converse that we have learned explains that. Okay, angle 4 and angle 15. They share this line D. So angle 4 and angle 15 are opposites and pointing outwards. So that's our alternate exterior angles converse, which tells us the lines they don't share. A is parallel to B. Angle 10 is congruent to angle 12. Those angles I could slide either 10 onto 12 or 12 onto 10. They share line B. They share this line right here. So they are corresponding angles. That's our corresponding angles converse. So line C is parallel to line D because those are the lines they don't share. Angle 9 plus angle 13 equals 180 degrees. Well, angle 9 is in between parallel lines A and B, or what we hope to be parallel lines A and B, but angle 13 is outside. We don't have a converse theorem or an angle theorem for one that's on the inside and one that's on the outside that share a line. We do know that that's true statement. Angle 9 plus angle 13 equals 180 because they share a line and they share a side. They are linear pairs. But linear pairs don't tell us anything about parallel. It's just another true statement, kind of like vertical angles. So that's a none. We can't say that they're parallel using this. Okay. Angle 2 and angle 7. They share the transversal line A. So angle 2 and angle 7 are congruent because they're alternating sides and in between the lines C and D. So that tells us that C and D are parallel because they're alternate into interior angles. So alternate interior angles converse tells us that the lines are parallel. Okay, and last one, angle 6 is congruent to angle 11. These lines don't share a transversal. 11 is on line D and line B, whereas angle 6 is on line A and line C. They don't share a transversal. So because of that, they do not have any of these angle properties. So none. They don't have a property to relate to. So we can't prove that lines are parallel. Okay, so number 2. Let's get some more practice in. Angle 9 is congruent. So angle 9 is right here. It's congruent to angle 22. They share the line S. So they have a transversal in common. And they also have two lines intersecting in between. They have line Q and line R. So here and here. So those angles, in comparison to those lines, are alternates of the transversal and aiming outward. So they are alternate exterior angles. So that's our alternate exterior angles converse. So the two lines that they intersect, that each angle intersects, are parallel. So Q is parallel to R. That's what we're saying. So even though there's that third line that we were trying to prove parallel, we're only comparing the two that the angles rest on. Okay, so angle 8 plus angle 13 equals 180 degrees. Well, angle 8 and angle 13 are in between lines P and Q. They share the transversal R. I'm sorry, the transversal T. So they're on the same side of the transversal, so that's consecutive, and they're in between, so consecutive interior angles converse. They're in between P and Q, so P is parallel to Q because of our consecutive interior angles converse. Okay, so angle 1 is congruent to angle 17.